Hey there everyone, Mr. Dickin here, and this is going to be the first video to kick us off into Unit 9. Unit 9 is going to be getting into something called sequences and series. We're going to be doing this at a very kind of basic level, and this is something that will definitely come into play later on in future math courses for you. One thing to kind of make note of on the online assignments, the day numbers, so like this is day 2, the day numbers are a little bit off. So like day 2's material might show up in what's titled as like the day 3 or day 4, I can't quite remember, assignment. So when you guys are working through them, there's a chance that you might need to watch like 2 or 3 videos before you can tackle the first assignment, and just kind of go with the flow on that one. All right, so before we get too far, let's get some vocab out of the way. You know the drill. If you need to pause, please do. A sequence is just a list of numbers separated by commas. Our goal for this unit is to be able to figure out a pattern for that list of numbers and then predict what number might come next or what might be like the 10,000th number on the list. Each number in a sequence is called a term. So here it says it's a list of numbers. Technically, you could argue it's a list of terms. The first term, second term, third term, fourth, fifth, sixth, seventh, eighth, so on and so on and so on. The way we represent this is with subscripts. Now, subscripts, let me write that there. Subscripts are when you have a small little number kind of below a letter. So let me go ahead, and this is going to be gross because I'm using a trackpad. A subscript might look like this. That's supposed to be an A. So A sub 7. All right, so that's what we're going to start seeing. It says that it's going to have the starting index be a 1, and that's because we always start with the first term, and then we list them out: second term, third term, fourth term, fifth term, so on and so on and so on. So this is what all of our sequences are going to look like when we try to generalize them. This means the first term, second term, third term, fourth term, and then just the random variable nth term. Okay? So the hard part that a lot of you are going to find here is actually the notation. All right? So that's kind of what we're going to try to work through here. So, like I said, a sub n would just be the nth term. And that's where we can say, like, let's plug in 50 for n. Well, that would be the 50th term. A sub 1 is the first term. A sub 2 is the second term. A3 is the third term. But then we have a sub n minus 1 and a sub n plus 1. And that's a general notation based on the fact that the nth term is just kind of like a variable, right, representing any random term. Then n minus 1 would be the term that comes directly before this term. So we're going to refer to that as a previous term. This, by the way, is going to show up quite a bit later on in this video and also following videos. So a sub n minus 1 is the one that comes right before our generic nth term. Kind of flipping that logic, a sub n plus 1 would be one more than this, so it would be the term immediately after. So it would be the next term. All right, let's continue our vocab adventure, shall we? Again, if you need to pause, please do. There are going to be 2 different ways to write formulas for getting our sequence terms. First is an explicit formula, and this allows direct computation of any term for a sequence. What that means is if I want to figure out what is the 70th term, well, I could just plug a 70 into a formula, and then it would spit out the 70th term in that sequence. Explicit form is great because we can figure out any individual term that we want without having to know much else. A recursive formula is slightly different. A recursive formula, you need to know 2 pieces of information. You need to know what is the pattern that you're doing. So they're kind of describing this as the recursive formula. And then what is the first term of your sequence? So you need to know what is the pattern you're following and where do you start. So if my pattern is multiplying by 2 and my starting number is a 3, then my numbers would go 3. Let's see if it'll let me write on here. 3, then 6, then 12, then 24, blah, 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 blah. So in order to get that pattern, I would need to know what is my starting number, and then what am I doing to each term to get the next one. Recursive formulas are really great if you need to just crank out the first 5 terms right one after the other. An explicit formula is kind of a pain to do that because you have to figure out, okay, what is the first term? Plug in 1. What is the second term? Plug in a 2. What is the third term? Plug in a 3. So let's see some examples here. First, let's use an explicit formula. For an explicit formula, you have an equation essentially, and it says to find the nth term, just plug in whatever your n value is to this formula, and it'll spit out your first term, or your second term, or third. So if I wanted to find a sub 1, that would be the first term of this sequence. I plug in 1 for n, 3 times 1 minus 2, and I'd get 1. I'll do the same thing for a sub 2. This is going to be the second term in my sequence. 3 times 2 minus 2, and I get 4. Do the same thing for 3. Do the same thing for the fourth term. As we continue this pattern down, you'll notice all of these resulting values that I'm getting, those are going to be the numbers of my sequence. So the first 5 terms of this sequence, represented by this formula, 3n minus 2, is 1, 4, 7, 10, 13. And we always write out the numbers in a sequence separated by commas, just like this. Second one, I want the first 5 terms of the sequence. So I'm going to be plugging in my index numbers, these little subscripts. I'm going to refer to those as the index values. So I'm going to be plugging those in for n. Now, a strange thing happens with -1 to the nth power. It's either going to result in a -1 or 1. And the way you can tell is if I raise this to an odd power, it'll be -1. If it's an even power, so squared, 4th power, 6th power, it'll be a +1. So I should anticipate seeing some results, maybe oscillating between 2 different values, or maybe oscillating between positive and negative, positive and negative. So let's see what happens for the first term. I plug in 1. -1 to the first is just -1. Add 3, I get 2. Plug in 2. -1 squared, well, that makes a +1. So +1 plus 3 is 4. To the third power, -1 to the third, well, that's a -1. Add 3, and I'm back to 2. If I were a gambling man, I'm probably going to guess that a 4 is coming next. Yep, because we raised to a 4th power, giving me a +1. Do the same thing for 5. And this one is actually just going to oscillate between 2 different numbers, 2, 4, 2, 4, 2, 4, 2, 4, yada, 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 yada. All right, so now let's see a recursive pattern. So a recursive pattern, you need to know 2 ingredients. What are you starting off with? What is the first term? And then what are you doing to the previous term to get the nth term? So this pattern says I'm going to take the previous term, so the highlighted piece, that is the previous term, and I'm going to add 2. So to find the second term, I'm going to take my previous term and add 2. So I'm going to take 6 and just add 2. Well, 6 plus 2, that's not too bad, right? That's just 8. To find the third term, I'm going to take my second term, which was 8, and add 2. 8 plus 2, that gives me 10. I'll take my third term and add 2 to get my fourth, take my fourth and add 2 to get my fifth. And as we go through and do this, you'll notice that each term kind of leads us to the next, knowing that the pattern is just take whatever came before it and add 2. So our sequence here would be 6, 8, 10, 12, 14. This one tends to be a little bit quicker and easier to just crank out the first 5 terms, boom, 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 boom. All right, next one. Here we have a recursive formula. I want the first 5 terms. Given that we're starting, first term is at 10, and the pattern here is 2 times n minus 1. I know there's not a little multiplication dot listed in there, but if you want to put a little times symbol in there, by all means go for it. So you're going to take whatever the previous term was, you're going to double it. So to find the second term, I'm going to take 2 times my first term, which was 10, so 2 times 10, I get 20. Then I'll multiply that by 2 to get 40. Then I'll multiply 40 by 2 to get 80. So again, I'm just multiplying the previous term. So A4, the fourth term, is just the third term times 2. So very quickly we can go through and we can get our first 5 terms without doing too much heavy lifting. So 10, 20, 40, 80, and 160. All right, that is it for this video. You know the drill, folks. If at any point you guys have any questions, please send me an email. Good luck, have fun, be safe, roll tide.